Hello everyone and welcome to my latest Rust Quickie. Last week I have talked about so-called move operations in Rust, and you have seen that heap allocated memory can only have one possible owner, and therefore you have a lot of different restrictions in Rust. And today I want to continue that discussion by introducing so-called references to you, which are solving all the problems that we have seen last week. So let's switch over to Visual Studio Code and let's work with references in Rust. I have here again a very simple function, and within that function I'm creating a new vector. That vector is allocated on the heap, and we are pushing here a few string values into that vector. And afterwards we want to extract some of those string values from the vector. As you can see, we are accessing here the SQL Server string at index 0 and the Oracle string which is stored at index 1. But as you can see, we are getting an error message from the Rust compiler because a move operation occurs. We are trying to move a reference to a string which is allocated on the heap, and we are trying to move that string into a local variable. This doesn't work in Rust. So the question is now how we can solve that problem. And Rust has here so-called references, and you can define a variable as a reference by using the ampersand sign. As you can see, I'm using here the ampersand sign, and the error message just goes away because we have defined here now a string reference. So that variable SQL Server just points to that string value which was allocated on the heap. It's just a reference. Just think about it like a pointer in C and C++. But as we will see in upcoming Rust quickies, those references are memory safe and they are also thread safe. So this is also very important. We are dealing here with safe pointers. They are memory safe and they are also thread safe. So this is very important. We are doing here the same thing with the Oracle variable. Again, I'm using the ampersand sign to define a reference to a string value, and therefore we can store that reference in that local variable Oracle. That local variable is again allocated in the current stack frame of our function, and afterwards we can just print out both strings to the console. So let's do a cargo 1 command, and as you can see, we were able to print out those two string values from the vector that was allocated on the heap. This works because we have declared both variables here as references. As you can see from my command, this is a reference, and a reference doesn't own the data. It just points to that string which is allocated on the heap. Means the owner of that memory location is still the vector v that we have defined here. This is very important. As I have said last week, you can only have one possible owner for heap allocated memory. So the owner hasn't changed. We're just using here a reference to point to some memory which is owned by some other variable that is currently in use. So very important here to know that fact. I have here the same function as last week, where you have seen that an ownership transfer happens when you are passing in a variable into a function which was allocated on the heap. As you remember from last week, Rust just generated us here a compile time error. I have defined here that variable databases again It's allocated on the heap. We are pushing here a few string values into that vector on the heap, and then we are passing now that vector as a reference into that function. And because we are using here a reference, the Rust compiler doesn't generate us a compile time error. Last week we got a compile time error because an ownership change was happening, but today we are passing in here a reference. When you look at the function signature, we have here a reference to a vector, and the vector itself has again references to string values. So it's a reference within a reference. Afterwards, we are looping over those values, we print out those values, and afterwards we can still access that variable databases because the ownership of that variable hasn't changed. The owner is still the variable databases because we have used here a reference, and therefore the ownership hasn't changed. So this is very, very important. The ownership hasn't changed here because we have used here a reference. And this is a so-called shared reference. Means you can only access that reference for read operations. When you try to change that variable somehow, for example, within that function you are trying to push a new value into that vector, the Rust compiler will give you an error message again because a shared reference is immutable. You can't change it. And therefore, I will also talk in my next Rust Quickie next week about mutable references. Today we have talked about shared references. They are just read-only. You can only read from them. When you want to change them, you need a mutable reference. So this is very, very important here. So as you can see with references, you can get rid of all those problems that you have seen in my previous Rust Quickie. I hope that you have learned today a lot about references in Rust, and I'm already looking forward to see you next week again. Thank you.